Okay, this is the P2 paper from October 2021. It's question number 7, and as you can see by looking at it, this is a sequences and series question. In particular, we're going to be doing some work on geometric series where we've got to find the sum to infinity. That's going to lead to some work where we'll need to know our laws of logarithms and solving equations with logs. But let's make a start. Quite a few parts to this question. So the first part, part 1, says geometric series has the first term a equals 4, r equals 6, common ratio equals 6. Given that the nth term is greater than 10 to the power of 100, can we work out the smallest possible value of n? Yeah, I absolutely can do that. Let's make a start then, part 1. So what we're going to say is that a is equal to 4, r is equal to 6, and we remember that the formula for the nth term is ar to the n minus 1. Now what they're saying is I want it to be, the term to actually be greater than 10 to the 100, but what I'm going to do is put it equal to 10 to the 100. So I'm going to say ar to the n minus 1 equals 10 to the power of 100. Then when I get n, if n works out to be 13.5 or something, I'll say n has to be the next term, which would be 14, the 14th term if we were doing that. Let's worry about that when we get there. Let's put our values in. So we're going to get 4, 6 to the power of n minus 1 is equal to 10 to the 100. And then here's my problem. I've got n minus 1 up in the powers there. So the way to get rid of that is to take a log of both sides. We're allowed to take log of both sides. I'm going to do log, which is log to the base 10. So log 4, 6, n minus 1 is log 10, 100. Now, once we've done that, we're now going to start using some of our rules. Our log rules, log AB is log A plus log B. And the other one that we're going to be using, we're going to have log A to the n in a minute, and we're going to call that n log A. We're going to be able to take the power down. That's the one that we use most often, I think, with our log rules. So I'll apply that one in a second. Log AB then applies to this left-hand side, doesn't it? So where I've got here log 4 times that, I can say log 4 plus log 6 to the n minus 1 is equal to log 10 to the 100. And then taking the power down, I can do it for both of them. Take the power down there. Well, this one I can just say is equal to 2 if you want. You can just put that into the calculator. So I'm going to get log 4 plus n minus 1 log 6 is equal to, we may as well work out that value, log 10 to the 100. Sticking to the calculator just works out to be equal to 2. And all I now need to do is to just rearrange and get n minus 1 from this, which is not complicated. So I'm going to say n minus 1 log 6 is equal to 2 minus log 4. So n minus 1 is equal to 2 minus log 4, all divided by log 6. That means that n minus 1 works out to be equal to, do that on the calculator. If you do that on the calculator, it comes to 127.7 something. I'm not really interested in that part. If that's true, then n equals 128.7. And as we said previously, so that would be if the value actually equaled to 10 to the 100. I want it to be bigger than that. So I want n to be the next integer, basically, that's bigger than 128, which means that n is going to work out to be equal to 129. Okay, so that's the first part done. Now the second part, quite interestingly, part 2, is just a completely different question. It's unusual that they do this, but they now say ignore everything from the first part. Different geometric series has a first term a, common ratio r, so a standard thing. Given that the second term is equal to minus 6 and the sum to infinity is equal to 25, can I show this quadratic? Yeah, I should be able to. Let's get started and do it. So 2, part A, just use the information they've given me. So they're telling me, when they tell me the second term is equal to minus 6, I can write that down. Okay, AR equals minus 6. And if they tell me the sum to infinity, the sum to infinity is a over 1 minus r. So that is going to be equal to 25. So here I've now got two equations that I can play around with. One thing just quickly to say is that if the sum to infinity is a over 1 minus r equals 25, then r has to be between 1 and minus 1, otherwise you can't use that. We can either write that like that, or we can say modulus r is less than 1. These two bits here are both true if we're using a sum to infinity. That'll come up in a minute. I'm going to get rid of that. That'll come up in a minute when I'm actually answering the final part of this question. So just to remind you of that. But yeah, going back to this, what we can do is from this equation, we can get that a is equal to minus 6 over r. And from this equation, we can get that a is equal to 25, 1 minus r. So those two can just be equated to each other. They're both equal to a, so they can both equal to each other. So I can get that minus 6 over r is equal to 25, 1 minus r. Now, I do have to go through and do all this simply because I'm trying to do the proof here, but it's basically finished at this stage here. Minus 6 is equal to 25r. 1 minus r, multiply it out. Minus 6 is equal to, do take your time, 25r minus 25r squared. Make that equal to a quadratic, get everything over to the same side. 25r squared minus 25r minus 6 is equal to 0, and that's what I was trying to do for part A. Part B says find the solutions of it. So part B is just going to be solving this quadratic. Only because I've done it already, I know that it does actually factorise here. You can stick into the quadratic formula if you want, but we should always have a go at trying to factorise, and this one does. It factorises to 5r plus 1, 5r minus 6 equals 0. If you go back to other parts of my channel, there's how to do videos which show you how to factorise those sorts of quadratics if you're struggling with them. But anyway, this is going to give me 5r plus 1 equals 0, which will give me r equals minus a fifth, and it's going to give me 5r minus 6 equals 0, gives me r equals 6 over 5. Well, that one's not valid. Why is that not valid? Because r has to be between 1 and minus 1. The modulus of r has to be less than 1, or that, I'll leave it as that one rather. Sorry, you could have said that. Would have been the same thing. Don't say both, just say one of them. So then it means that the left-hand one is actually my answer here. R is going to be equal to minus a fifth. And that's part two. So what was B? So B is actually, be careful about what I'm doing here, sorry. So the two solutions to that equation are that, and then part C is to say R equals minus a fifth. Because modulus of r has to be less than 1. Because. Okay, so just make it clear, just in terms of actually answering the question, go back and just read the question again, just make sure exactly what we've got. Two solutions are those two, and then part C, I was trying to get ahead of myself a little bit. And then part D says find the sum of the first four terms of this series. So for part D, we've got that the sum of n terms is equal to a 1 minus r to the n all over 1 minus r, and they want the sum of the first four. So S4 is equal to, do I know what A is, or have I got to go away and work it out? I haven't worked out what A is yet, so I'll do that now, sorry. Actually, let's just show me working out for that. Get rid of that there. Sorry, yeah, so if AR equals minus a sixth and R is minus a fifth, A minus a fifth equals minus 6, which means that A works out to be equal to 30. So now S4 is going to be A, which is 30, 1 minus R to the 1, 1 minus minus a fifth, sorry, to the n, which is to the 4, all over 1 minus a fifth. Just take your time to put that all in. I'll rush through that a little bit. So yeah, a 1 minus r is minus a fifth to the power of n, all divided by, be careful of the negatives there obviously as we're doing it, and if you stick that all in, that all works out to be 24.96. Let's just go back and make sure. It doesn't say anything, so it doesn't say about how many decimal places or significant figures. I'm quite happy to leave it to what I've got it to there, and that's the end of that question. Hopefully that all makes sense.